Good afternoon. My name is Kim Schaefer, and I'm a cloud infrastructure engineer. And today what I want to talk to you about and share with you is my Kubernetes dungeon crawl project and how Grafana ended up playing a role in tying it all together. So the basic inspiration behind the game and the project was a combination of KubeDoom and Doomfana. And basically what I decided to do was take an old school dungeon crawl game called Brogue, and since it's open source, I was able to adapt it to run in a Kubernetes cluster. And I really wanted to focus on using operators and CRDs so that I could have what happens in the game impact what happens in the cluster and vice versa. So actions in the cluster would have an impact on the actual gameplay. To help explain that a little bit more, let's take a look at what happens when a creature comes into the game. So the first way that happens is through the normal gameplay, a monster spawns. Whenever that happens, a deployment in the monster namespace is created that represents that monster. And in that deployment, there's an Nginx pod, and that pod has a custom landing page that shows you all the details and stats about the monster. And as you engage with the monster, you're going to see updates on that page. So if you start attacking a monster, you're going to see that health go down on that custom landing page. The second way a monster gets into the game is if you create a pod in the monster namespace. That's going to then cause a monster to spawn in the game, which then recreates what I just talked about with the monster deployment. The second area of the interaction is when a player kills a monster. So the first thing that happens when you kill a monster in the game is any deployment out there that represents that monster is going to be destroyed. And now, if that monster happens to have a monster pod that represents it, that pod is going to be destroyed as well, but because of the magic of Kubernetes, that pod's going to come back, which is going to basically bring that monster back to life in the cluster. So the real lesson behind that was be careful how many of these monsters you create, because you can make the game extremely difficult if you keep creating these monsters. Now, every game needs a cheat mode of some sort, so what I did is, if you're in the cluster and you delete a deployment, that's going to kill the monster in the game. Likewise, if you delete a monster pod, that's going to delete the deployment, delete the monster, but then again, that pod's going to come back to life, and that monster is going to come back to life. The key project segments for what I did was, first, there was the game. I went in and I modified it so that it can use post and GET requests to get information in and out of the game. The portal is a Flask API that kind of has those endpoints that the game interacts with, but then it also can create, update, and delete CRDs that represent the monsters. That's how you get that connection between the game and the cluster itself. The Kubernetes controller that I refer to as the Dungeon Master is basically what makes all the magic happen within the cluster. As I went through and was putting everything together, I then realized that I really needed a magic mirror, because as you're going to see here in a second, there's all sorts of pages and screens and displays, and I needed a way to tie it all together, and that's where Grafana came in. So this is just a screenshot of the game. I have a video of it later on so you can see the actual interaction. The only way that you can really tell what I've done on this screen is you'll notice where it says Muncie 21 and Jackal 4. The numbers that are after the names there, I put in there to make it easier to associate the monsters in the game with the pods and deployments in the clusters. The Muncie is an actual monster in the game, but I gave it that tag of Muncie so that you can tell that very quickly that it actually represents a pod. For the portal itself, you have a basic landing page, but then you can also go in and take a look at all the monsters that are both alive and dead in the cluster. Importantly, if you take a look, you'll be able to see that those monster names for the alive monsters are links. That's the easy way that you can get to see these pages that show you all the details of that monster. And of course, to make it fun, I had to add a red button at the bottom so that if you just want to kill the monster and not deal with it, you can just click the red button. Yes, I know you can use kubectl commands, but the red button is just much more fun. You can take a look at all sorts of player information and equipment. You can take a look at game state information about levels and gold and things like that. You can also take a look at just the Muncies, and remember, those are the pods, or the monsters that are created from pods in the monsters namespace. They have the same play in the game as any other monster, but they're created by the pods. So this page I set up largely to make it easy for me to quickly generate those pods. But then, of course, I had to have more red buttons to kill more things. Now, there were times where I would either try to visit a monster page before it was fully up and running, or I'd try to visit it after the monster had already been killed. The standard 401 page or 404 page just wasn't doing it for me. So to just have even more fun with the project, I created my own custom 404 page that has its own separate setup within the game. It doesn't affect anything, it just makes it more fun. This screen is basically just showing you that before I had the dashboard, to interact with the cluster, I would either use K9s or kubectl commands. There's nothing wrong with that, but as you can see here, this was a much better solution. So I'm not actually playing the game live because I'm just not good enough at the game to do that. So this is recorded, but you can see that as I play the game, you can see the stats on the right-hand side will update. You'll be able to tell when I kill a monster because you'll see that monster count, like what just happened. It'll go from 6 to 5, and then it's going to go back up to 6 because that pod was recreated. So you can see everything right there. The bottom row is actually just stats coming from the cluster itself, just because I figured since it is a Kubernetes project, I should have something Kubernetes related on the dashboard. Now, the key learning points that I got from this is one, configuration. I wanted to be able to literally enter one command and have everything come up. I didn't want to have to go back in and do any sort of configuration to get the Grafana dashboard done. So what I did is I went through and I set up in the container for Grafana, I have everything as a config map, so I don't actually have to do any manual configuration of that dashboard. It just comes up with one command, everything running. Embedding was also important. That dashboard, without being able to play the game from the dashboard, just wouldn't be the same. So it really showed me that being able to tie in different types of video or live streams into the dashboard can make a huge difference on how useful and helpful that dashboard can be. The data that I was working with, I have Prometheus metrics, I've got the data from the API, and then data that I can get from the cluster itself. And what I learned is there are some things that I needed to have real time or close to it. So for example, if you're attacking a monster and all, you need to be able to see your health in real time to know how much danger you're in. There's other things like the statistics about how much gold you've collected over time, that can come from a Prometheus metric instead, because you don't need to have that real time. So it just made me realize that you really need to think through and identify what your data sources are and which one is best for which purpose. So thanks for coming and letting me share my project with you. The next steps for the project are, one, I want to be able to start drilling down into those metrics on the dashboard. You saw all the data that I'm actually collecting from the game. I'd like to pull more of that into the dashboard as drill downs. I love playing this game on my local computer, but the next step is going to be to get it up and running in a Google Cloud GKE cluster, because I just think it's so much fun that it belongs out in the cloud. And there's also some more things I want to do working and exploring with the CRDs and the controller. If you want to stay in touch, I'm happy to answer any questions or just chat about the project in general. And you can also check out the GitHub repo, where you can also take a look at the different architecture diagrams behind the project. Thank you.